Factoring by grouping. So this is when we're factoring a trinomial and we're going to use the method of grouping. We've already learned about the 1am method, but in examples such as these, we can't use it because the leading coefficient is a number that is not 1. So let's take a look at this first example. When I look at this, I should always try everything else first. Is there a GCF? No, because there's no number that fits into 2, 9, and 10. So there's no GCF in this case. Can I use 1am? No, because the leading coefficient isn't a 1. So it doesn't qualify for 1am. So we're going to go ahead and factor this by grouping. Now, a lot of times you may have heard this being referred to as the headphones method, and that's because the very first step is to take the leading coefficient, which in this case is 2, and this last term, which is positive 10, and multiply them together. And when I put this line, putting that I'm going to multiply them together, it tends to look like a set of headphones. So I get 2 times 10, which is 20. So I'm going to look for all the numbers that multiply to give me a positive 20. And similar to 1am, I still want them to add to this positive 9 on the inside. So let's take a look at the numbers that multiply to positive 20. Again, using the same method as 1am, if I take 20 and divide it by 1, I get 20. So 1 times 20, or negative 1 times negative 20, will give me 20. 20 divided by 2, 2 times 10, or negative 2 times negative 10 will give me 20. 20 divided by 3, that's an ugly decimal, so I'm not going to put 3 on my list. But 20 divided by 4 works. 4 times 5 will give me 20, or negative 4 times negative 5 will give me 20. And if I was to do 20 divided by 5, I'd get right back on my list and see that 4, so I know I'm done. Now if I start adding these together, I'll get all of my sums, and that'll help me to decide which set I'm going to use for my middle term. So 1 and 20 is 21. Then I have negative 21, positive 12, negative 12, positive 9, and negative 9. So the two numbers which added together will give me that positive 9 is this positive 4 and positive 5. So what I'm going to do now is something a little bit different. I'm going to split up that middle term. So I'm going to write that first term exactly how you see it, 2x squared. I'm going to write that last term exactly how you see it, plus 10. But I'm going to change that 9x to be plus 4x and plus 5x. Now that's allowed because 4x plus 5x is just 9x, so I'm just writing things a little bit differently. And the whole purpose of me doing that is I can split this polynomial right down the middle, and I can factor each side separately before bringing it together. So what you're going to do is you're going to find the GCF on the left side and the GCF on the right side. So on the left side, what number and letter fits inside both? 2x. And if you need help with that, go to our GCF video. So if I pull out a 2x in each of these expressions, I'll be left with x plus 2. Now if I take a look on the right-hand side, my GCF is going to be a positive 5. So if I pull that 5 out of the left-hand side and the right-hand side on this expression, I'm going to be left with x plus 2. Now, if you're factoring by grouping, having those parentheses look exactly the same is how you know you're doing it right. Because now you're going to pull that parenthesis out as a GCF. So you're going to have x plus 2 as your first parenthesis, and your second parenthesis is going to be what's left over, 2x plus 5. And just so you know, mathematically speaking, it's because you're pulling that GCF of x plus 2 on both sides, so they're reducing. But sometimes people just remember that the parentheses that's repeated goes in one, and then what's left over goes in the other. And I'm fine with that. So the cool thing about grouping is that it always works. 1am only works if the leading coefficient is 1, but grouping will work no matter what the situation is. So let's take a look at another example. Just one more. If I write the example 2x squared plus 5x minus 3, and I see if I can pull out a GCF, but I can't, right? There's no number other than one that's going to go into 2, 5, and negative 3. So that's when I'm going to start using my headphones method here. I'm going to take this positive 2, and I'm going to take this negative 3, and I'm going to multiply them together, right? 2 times negative 3 is negative 6. Now I'm going to list all the numbers that multiply to negative 6. I have 1 and negative 6, negative 1 and positive 6. I have 2 and negative 3, negative 2 and positive 3, and then I'm done. So let me slide all these over because I'm going to need to add those to see which one's going to give me my positive 5. Remember, I want these numbers to add to this positive 5 term in the middle here. So 1 plus negative 6 will give me negative 5. Negative 1 plus 6 will give me positive 5. Ooh, that's the one I want, but let me just double check. Over here, I'll get negative 1. Over here, I'll get positive 1. So I was right. It is that negative 1 and positive 6. So again, the expressions that are in the headphones stay. We don't get rid of them. We just write that middle term down differently. Instead of writing 5x, we're going to write minus 1x, and we're going to write plus 6x. Now we're going to go ahead and split the middle and find the GCF on both the left side and the right side. On the left side here, I see that there's no number other than 1 that'll go into both, but I can pull out an x. And if I do pull out that x from each of them, I will be left with 2x minus 1. And on the right-hand side, I see that both of these are factorable by 3. So I'm going to pull out a 3 from each. That's that positive 3 that I pulled out. And what am I left with? 2x minus 1. I know I did a good job because my parentheses match. Now the final step is just to pull out that repeated parentheses and then write what's left over, x plus 3. Again, I want to emphasize that this will work all of the time. You still need to pull out a GCF first, but after you try to pull out a GCF, whether it has a leading coefficient of 1 or any other number, this will always work. This is factoring by grouping.